Hello, welcome to the Phoenix Water Conservation Institute. This is Lesson 1 of your Phoenix Water Wrangler Volunteer Training. The Phoenix Water Conservation Institute is a hub for conservation-minded volunteers to learn more about water conservation in Phoenix and engage with our communities on these topics. The curriculum provides information about the effects of drought and shortage conditions that impact Phoenix's water supply. The training will also encompass the history of water, how we manage water in Phoenix, and water conservation in general. We'll start with Lesson 1, which is Water 101, and this will take us through the program and help you establish a water knowledge baseline. To introduce myself, my name is Laura Van Lith, and I'm your volunteer coordinator. My position with the City of Phoenix is a water resource specialist, which encompasses a variety of tasks, including managing this program, our community educational workshops, and overall water conservation policy action in Phoenix. We have most likely already been in touch, but I will be your direct contact for most things Water Wranglers, so feel free to email me if you have any questions. Our vision in the Water Services Department is to provide superior water services for perpetuating environmental excellence and focusing on safety. Our mission is to provide high-quality, reliable, and cost-effective water services that meet public needs and maintain public support. Within the Water Services Department is the Water Conservation Office. This is my team, and we are tasked with achieving efficient and responsible water use for all throughout the City of Phoenix service area. But who exactly are we, and what do we do? Well, we're a public water utility, a steward of water resources, a member of the community, and an institution that serves our community. As a provider of water, we're constantly thinking about water availability, so planning and stewardship are of equal importance in our work at the Water Department. We must understand that we must first ensure that there's water available before we can actually treat and deliver it. And this is where you come in. A water wrangler is a volunteer. Your participation in this program is entirely voluntary. We love the support of interested community members like you, but we also understand that you have lives of your own outside of volunteering. So typically, you can sign up for volunteer events as they come and when you're available. Wranglers function as community representatives for the City of Phoenix and sometimes act as change makers for water conservation topics. Most importantly, as a Wrangler volunteer, you are an informed member of the public. Though water wranglers have a very important role to play in achieving community-wide conservation, remember, you're not a City of Phoenix employee. Additionally, you're not expected to be a water expert. It's okay to tell a member of the public that you don't know the answer to something. This is important to remember because we never want to make a guess or assume and end up delivering misinformation. This is also important because you are volunteering and representing the City of Phoenix, and we have very strict standards for transparency, accuracy, and equity. Our staff will always work with you to get those people the right answers. Finally, you're never obligated to speak with any person who makes you feel uncomfortable. We'll cover these topics in later modules when we practice together, but our main priority is to keep you all safe and comfortable. A water wrangler has many important roles. Through the process of communicating with citizens, wranglers can build relationships and trust. Through outreach, wranglers achieve a physical presence within the community. In practicing engagement, wranglers listen to the community, thereby giving citizens a space to share their worries, needs, and opinions. Wranglers also lower barriers to water conservation education by teaching, demonstrating, providing assistance, and sharing with members of the community. And finally, through all these roles, wranglers are helping to deliver a call to action, which is to encourage community members to voluntarily adopt water conservation practices. So where do wranglers fit into Phoenix Water? We know that wranglers already care about water, and they know how to encourage others. You guys also have a unique attribute. You're not government employees, so people might want to talk to you more. Wranglers are one of the most important ways to connect deeply with our community and inspire change. So Phoenix Water created this program in hopes to achieve these goals. Our next topic will go over water in general and talk about where it comes from. So, where do you think Phoenix's drinking water comes from? Is it the Salt River, oceans, groundwater, Verde River, the Colorado River, or the Gila River? If you guessed the Salt River, groundwater, the Verde River, and the Colorado River, you'd be correct. F, the Gila River, is kind of tricky. Although it's very close to Phoenix, we actually do not get drinking water from that river. Instead, we send our runoff, in other words, we drain our water into the Gila River. That eventually will join up with the Colorado River one more time before it goes into the Sea of Cortez in Mexico. We also do not get our water directly from oceans. Here's a graphic of that idea. Our drinking water is coming from 4 main sources. We have a regional water supply that is shared by multiple states, countries, and sovereign nations, and that is the Colorado River, seen here as the green slice of the pie. We also have 2 local supplies that are the Salt and Verde rivers, and that is seen in the blue slice. Finally, we have the 4th supply, which is groundwater. You can see that we only use 2% of our deliveries from groundwater, and the remaining 98% of our deliveries are coming from surface water. In Phoenix, we treat groundwater kind of like a non-renewable resource, very sparingly. While groundwater does renew over time, it takes a very long time and cannot recharge as fast as we pull from it. Essentially, it's a finite resource, so we're saving it for when we need it most. In the meantime, we instead use a very diverse collection of surface waters. Now we're going to zoom out into the big picture. Watersheds. A watershed is an area surrounded by mountains with all water draining into a low point. If you ever volunteer with us at a water festival, this is the most important lesson to repeat over and over to your students. Now I'm going to ask you, anytime you find yourself out and about now, I'd like for you to look for the highest point that you can see. Is it a mountain? Now I want you to look for the lowest point. Maybe it's a canal. This is all a part of a watershed. As long as you are on the ground, no matter where you are, you're always in a watershed. An example of where water in a watershed goes is a river. And here we have an example of what that can look like in Arizona. Rivers in Arizona can look like the dramatic desert waterfall, the Grand Falls, seen on the left, or it could look like the Placid Mountain tributary on the right, which is the West Fork of the Little Colorado River. It just depends on where you are. These 2 waters are actually the same river, and they're going to travel northwest to the Big Colorado River. Grand Falls on the left is where the Little Colorado River is coming very close to joining the main stem of the Colorado River itself. And on the right, we see the same Little Colorado River over 150 miles southeast of this waterfall, at the base of Mount Baldy. This is a beautiful example of how water travels through our state, and although these places look very different, they're the very same river and have the same water. The watershed that we share regionally is the Colorado River Basin. 40% of our drinking water comes from this source. It currently serves 7 states, 30 indigenous communities, 2 countries, the US and Mexico, and more than 40 million people. The states that it serves are Colorado, Utah, Wyoming, New Mexico, Nevada, California, and Arizona. Now, the 40% that we currently get is expected to change as we make new Colorado River agreements, where the upper states and the lower states debate their allocation of the river water. Now this image gives a very complex visual of local watersheds and sources. You might see that there's a lot of blue lines here. Not all of these features are permanent water features. Some of them are ephemeral, meaning they go away depending on the season or if it has not rained. Around the middle, you can see the Salt River, the Verde River, and the Gila River. Coming down south, along the border, is the Colorado River. If you ever wondered why the left border of our state looks like that, it's because it follows the Colorado River. And right in the middle, here we are, Phoenix, and these little brown lines represent canals. Now we will move on to water cycles, which are actually more like a system than a cycle. We don't really like the word cycle necessarily because it implies that everything is sort of linear, one thing after another. But there are a bunch of little pit stops or side quests along the way. For example, let's start with snow. Let's say that we're snow and we fall on the high peaks of the mountains. It's super cold up here, so we turn into snowpack or a glacier during the winter. As the weather heats up, we start to melt and turn into liquid water, which gravity then takes us down the mountain to do some erosion on the way. About midway through, we might enter a river, which were then diverted into reservoirs or canals that cities use to distribute water to residents safely and efficiently. After the city uses us, we may flow out of the city as runoff or stormwater, and eventually make it into the ocean. But we're not done yet. The ocean then can get hot and we can start to evaporate and condensate into clouds. Then maybe the wind will take us back over the land and we rain somewhere else. This is only one path that we could have taken as water. We could have instead gone into the groundwater table and eventually make it out into the ocean. Or we could have come out of the ground as a natural spring. There's so much that water can do, which is why the water cycle is more like a complex system. Let's start to break down the water cycle. We can start anywhere in the cycle or the system, but let's start with evaporation first. Evaporation can be steam rising off the surface of a body of water, or evapotranspiration, which is essentially plant sweat. Evaporation happens when the sun heats water up, and these liquid water molecules get aggravated from the heat until they have enough energy to transform into a gas. Another process of the water cycle is condensation. After water evaporates and floats up, it'll cool down again, heats up, and cool down again, and this is how condensation occurs. Here's an example of that happening. All of the water drops are gathering up, like we might see on a car window, or we could see this on a larger scale, like clouds in the sky. These are both forms of condensation. Now, once the clouds get heavy enough and can't hold all this condensation anymore, we sometimes see precipitation, and that can be seen as sleet, fog, rain, or snow. When precipitation builds up, it can do the next step, which is runoff or infiltration. Runoff leads to water gathering as surface water, like rivers or streams. Infiltration, on the other hand, is when water soaks into the ground after it rains to become groundwater. It's kind of like the earth taking a drink, and we also can call it groundwater recharge. Now, runoff is water that does not soak into the ground, but instead flows over the ground to reach streams and rivers. Runoff only becomes stormwater as it flows into an urban or human-populated environment. We call it different things because stormwater picks up a lot of new and different pollutants like oil, trash, chemicals, and more. Now we will move on to a hot topic, quite literally, which is drought and shortage. A drought is defined as an extended period of below-average precipitation. Drought is purely abiotic, meaning it's driven by non-living conditions, like weather, time, or the natural cycles of our environment. Shortages, however, are both biotic and abiotic. A shortage occurs when the demand for water is greater than the current supply. And our current shortage is caused by humans and environmental factors. On a regional scale, we're currently experiencing some of the driest conditions in over 1,200 years. And because of this, we are seeing lower flows overall. Phoenix expects to receive less Colorado River water because of these conditions, and because of the agreements happening between the upper states and the lower states. So how exactly do we measure drought? Do we use rocks, trees, fish, clouds, or dirt? The answer is actually all of them. A rock can help us measure through geological record. You can see a whole story in the erosion and weather events that are recorded in the rock or the soil profile. By trees, we mean studying tree ring data, and that study is called dendroclimatology. Fish is also correct. We can't just ask the fish if there is a drought, unfortunately, but we do know that fish rely on dissolved oxygen levels, which is another factor in measuring drought. Clouds can help us measure relative humidity, rates of precipitation, and evapotranspiration. And finally, dirt is helpful in measuring soil moisture. All of these are ways to measure drought. Now let's talk about the star of the show, the Colorado River, which is currently being affected by long-term drought and climate change. Now this is when it's important to remember the difference between drought and shortage. Cyclical drought is a normal part of life in the desert Southwest. We built dams and reservoirs specifically to mitigate this problem, and that's how we're able to live here. But shortage is different. This is when we're dealing with drought and climate change. Our current drought is one of the longest and most serious droughts in over 1,200 years, and it's expected to grow worse due to a changing climate. As a result of the Stage 1 Water Declaration, the city began an intensive public education program to assist all customers in understanding the state of emergency and the need for voluntary conservation. This is when we created the Drought Management Plan. Because of the Drought Management Plan, the City of Phoenix has declared a Stage 1 water alert, which indicates that there is an insufficient supply situation that appears likely. This means that we need to take precautions and we need to have a greater effort in saving water. And all of this is why we encourage a desert mindset. This means that we are embracing our landscape and our climate, as well as respecting water as a precious resource, and finding ways to live and thrive in an arid climate. The desert mindset is not a scarcity mindset or a persecution complex. We do not want to cause anxiety, and we don't need to immediately move out of the desert. So we encourage a desert mindset over any overwhelming feelings of scarcity and persecution, or placing blame on others. The desert lifestyle means that we're making the choice to use water efficiently and responsibly while planning ahead and saving for later. The water conservation community is composed of the people who want to help others adopt the desert mindset, and a culture of conservation is a community-wide attitude where water is always used efficiently and responsibly. To learn more about the desert mindset, our website is Phoenix.gov/savewater, and here you can check out all of our resources and tools to make sure that you are using water efficiently and responsibly. I highly recommend checking it out before our next lesson, where we will talk about water conservation more thoroughly. Thanks for joining, and I'll see you in the next one.